Hey everyone, welcome back to the channel Code with AKJ. Today is day 53 of solving LeetCode Send 5 challenge, and today we are going to start a new module. It's binary search. The problem we'll solve today is guess number higher or lower. A simple yet perfect problem to kick off the binary search. So if you're new here, don't forget to like this video, subscribe to the channel and turn on the notification bell so you never miss daily problem solution videos and updates. Alright, so let's jump straight to the problem statement. So the problem statement says we are playing the guess game. The game is as follows. I pick a number from 1 to n. You have to guess which number I picked. The number I picked stays the same throughout the game. Every time you guess wrong, I'll tell you whether the number I picked is higher or lower than your guess. So you call a predefined API int guess, which takes a number num, which returns three possible results. So -1, which means your guess is higher than the number I picked. 1, the guess is lower than the number I picked, and 0, your guess is equal to the number I picked. So let's quickly understand the problem statement. So we are playing a guessing game. So you have to guess a number that I have secretly picked between 1 to n. And every time you make a guess, a special function called guess tells you whether your guess is too high or your guess is too low, or your guess is exactly correct. So if it is too high, we'll get our answer as -1. If our guess is too low, we'll get 1 as an output, and if our guess is exactly correct, then we'll get our answer 0 from this given function guess. And our task is to find the exact number I picked using as few guesses as possible. So let's understand this with this given example 1. So for given n value 10, if suppose we guess number 4, then we'll get answer as 1. That means our guessed number is lower than the actual number. So we need to guess little bit higher. And if our another guess would be 6, then this given function will return 0, which means we have exactly guessed the number, which means 6. So our answer would be 6. So let's start with our first approach, that is the brute force approach. So it's pretty simple. We can literally check each and every number from 1 to n, and we'll pass that particular number to this given guess function, and whenever we'll get answer as 0, which means we have guessed correctly, so we'll return that particular number I. And the time complexity of this approach would be O of n, as we are looping through the number from 1 to n, and the space complexity here would be O of 1. So let's quickly try run this code. So if suppose the n value is 10, we'll loop through 1 to 10, and we'll pass on each and every value to this guess function. For I is equals to 1, the guess function would give us value 1, and coming to the next value, if I value 2, then again our guess function would give us 1, which means the number we have guessed is actually lower than the actual number. So in the same way it goes till n, and whenever we reach I value 6, our guess function would give us output as 0, which means we have exactly guessed the number. So we'll return this I value, which means 6. So in this way our first approach works. So it is pretty simple, and the time complexity here is O of n, as we are looping through 1 to n value, and the space complexity is constant. So let's quickly code this approach and let's submit. So here's the code for our first approach. So here we are using for loop, which goes from 1 till n, and we are passing each and every I value into our guess function, and whenever we'll get our output as 0, which means we have accurately guessed the number, so we'll return I value. And if we loop from 1 to n and we didn't found any value, then we'll return -1. So let's quickly run this code. It's working, so let's submit. As you can see, this approach gives us time limit exceeded, because this works fine for small n values, but if the n value is huge, say close to 2 power level, then this approach becomes very slow. That is why we got time limit exceeded for large values of n. So now let's quickly optimize this using binary search, which is our approach 2. So now think about it. Instead of checking all the numbers from 1 to n, so we can just eliminate half of the search space with every guess using binary search. So in our approach 1, we were trying to loop from 1 to n, checking each and every number and passing it to our guess function. Since this 1 to n would be our search space, and based on the output of our guess function, we can just eliminate half of the search space. So for example, for a particular I value, if our guess function is 1, which means we have guessed the number lower than the actual value, then we'll just eliminate the half of the value, that is from 1 to I minus 1, as the value which is preceding to this particular I value will also give us the guess value 1. So in this way, we'll just eliminate the search space, and we'll just move on to the next possible search space to find our actual guess value. So this is how our binary search works in our approach to. Steps here would be that to maintain two pointers, that is low value as 1 and high value as n value, and we'll find the mid value. So to find the mid value, our formula would be that low plus high minus low by 2. And the next step here would be to pass this particular mid value to this guess function, and we'll get the output from our guess function, and based on that output we'll move these two pointers into our search space. So if the guess function returns 0, which means we got our answer, and then we'll return our mid. But if our guess function returns 1, which means our guess is too low, so we'll search in the right half. So for particular I value, which is our mid, so if this mid value gives us 1, then we'll eliminate our left search space and we'll find the next values inside right part. And in the same way, if our guess function gives us -1, which means for this particular mid value, we got our -1, then instead of searching in the right space, we'll move our pointer and search our guessed value inside our left search space. So in this way, we try to eliminate the search space and reduce the number of checks with the help of our output from the guess function. So we'll keep doing this until we find the number. So the time complexity of our binary search approach here would be O of log n, and the space complexity here would be same, which is constant. So this was the approach 2, where we have used binary search and eliminated the search space range with the help of two pointers, finding the mid value and sending it to the guess function. And based on the output of the guess function, we have reduced our search space and moved to the next possible search space with the help of these two pointers, low and high. So let's quickly code this approach and let's submit. So here's the code for our optimal approach, where we have used binary search algorithm. So here I have taken two pointers, low, high, and peak. So peak generally stores our answer, which would be initially 0. So we'll run a loop until or unless low is less than or equals to high. We'll find our mid value with the help of this particular formula, and we'll send this mid value inside our guess function, which would give us an output which would be stored in result variable. And based on the result variable, we'll move our pointers accordingly. So if the result value is 0, which means we have guessed the accurate value, so we'll store that mid value inside our pick variable and we'll break from the loop. And if the result variable is -1, which means I have guessed higher value than the number we should guess, so we'll move our high pointer to mid -1. And if the result value is 1, which means we have guessed lower than the number we should guess, so we'll move our lower pointer to next half, which is mid +1. So we'll do these steps until or unless we get our pick variable. If we found our actual guessed number, then it would be stored in our pick variable, and if not, we'll return 0, which would be our default value. So before running the code, let's do a quick try run on this given example 1, which is n value 10. So for n value 10, low pointer would be pointing to 1, high value pointing to 10, and mid value would be low plus high minus low by 2, which is 1 plus 9 by 2, which gives us 1 plus 4, which is 5. We'll send this 5 value inside our guess, and it generally gives us 1, which means we have guessed a lower number than the actual number. So we'll move our left pointer to the next possible search space, which is low to the mid +1. So again, our low would be pointing to 6, high would be pointing to 10. Again, we'll find our mid value, which is 6 plus 10 minus 6 by 2, which is 6 by 2, which is 8. So we'll send this 8 inside our guess function, and it will give us output as -1, which means we have guessed higher than the number we should have guessed. So we'll move our high pointer towards the left. So again, the low pointer would be pointing to 6 and high pointer would be pointing to 7. So again, we'll find our mid value, which is 6 plus 1 by 2, which is 6. So now we'll send this 6 to our guess function, and in this case our guess function would return 0, which means we have exactly guessed the number. So we'll store this number inside our pick variable, that is 6, and we'll return this pick variable at the end of our while loop. So in this way our binary search works in this given problem statement, and it is optimized for higher values of n also. So let's quickly move on to our code. So let's quickly run this code. Yeah, it's working. So let's submit. As you can see, this approach gives us successful submission as it is optimized for higher values of n. So that's the power of binary search, as we have picked our correct number value 6 and we found it in just 3 guesses instead of checking all 10 numbers which were in our first approach. And that's it for today's problem. We have started with a simple brute force solution and then optimized it beautifully using binary search. So if you found this explanation helpful, don't forget to like this video, comment your thoughts below, share it with your friends, and of course subscribe for more daily LeetCode certified challenge solutions. So I'll see you tomorrow with day 54 of the challenge, continuing our binary search journey. Till then, keep practicing and keep growing. Thank you.